Hey everyone, welcome back to AA STEAM series. Last time we checked out static electricity and how it can build up. Today we're switching gears and talking about electrical circuits. Circuits like the roads that electricity travels on, powering everything from little light bulbs to huge cities. We'll be looking at the key parts of a circuit, like batteries, wires, and resistors, and how they team up to control the flow of electricity. We'll also explore different types of circuits, like series and parallel circuits, and how they each have their own special uses. So let's get ready to learn all about circuits and how electricity flows. Think of a circuit like a water system. Voltage is the water pressure. It pushes the electrons through the circuit, just like water pressure pushes water through a pipe. Current is like the flow rate of water. It measures how much water is flowing through the pipe at a given time. Just like current measures the number of electrons flowing through the circuit. Now let's break it down even further. Voltage or potential difference is a difference in electrical energy per charge between 2 points in a circuit. It depends on the difference in the number of electrons between one end of the circuit and the other. The greater the difference, the more energy is available in the circuit. Voltage is measured in volts and tells us how much energy each electron carries. To measure voltage, we use a voltmeter, which must be connected in parallel to the circuit, which we'll get to later on in the video. On the other hand, current measures how many electrons flow past a point in a circuit over time. It measures in amps. To measure current, we use an ammeter, which must be connected in series with the load. So just like a water system needs both pressure and flow, an electrical circuit needs both voltage and current to work properly. First up, we have series circuits. Think of these as single-lane highways for electrons. Series means in a row, and that's exactly what it is. Electrons only have one path to flow. Because of the single path, the same current flows through every single load in the circuit. We represent this with the equation: the total current, or I, is equal to current 1, current 2, current 3, and so on to current infinity. So if we add more light bulbs or loads in a series circuit, each light bulb will get dimmer because the current is the same but distributed across more loads. Also, the voltage of each load adds up to the total voltage supplied by the battery, or the total voltage equals V1 plus V2 plus V3 plus V infinity, and so on. Now, let's switch gears to parallel circuits. These are like multi-lane highways. Parallel means the electrons have multiple paths they can take. When the electrons reach a fork, they split. But here's the key: every electron leaving the battery has the same amount of energy no matter which path it chooses. So the voltage across each branch is the same as the voltage of the battery. The total voltage equals voltage 1, V2, V3, and so on. However, the current is divided between each path. The total current is the sum of the current in each branch. So the total current, so IT, is equal to I1 plus I2 plus I3, and so on. This means that adding more paths doesn't reduce the brightness of the bulbs in the other paths because each path still receives the full voltage. So to summarize, series circuits have one path, the same current, and voltage adds up. Parallel circuits have multiple paths, the same voltage, and current adds up. AC, or alternating current, means the current goes back and forth. It's commonly used in homes and buildings. For example, the wall outlets in your homes. DC, or direct current, only flows in one direction. It's most commonly used in batteries, small electronic devices, for example phones and flashlights. AC, or alternating current, has a significant advantage over DC when it comes to long distance transmission. This is due to the ease of which AC voltage can be stepped up or down using transformers. Higher voltages cause lower current for the same amount of power, which reduces power loss due to the resistance in the transmission lines. This makes AC much more efficient for transmitting electricity over long distances, which is why it's a standard for power grids. DC, on the other hand, is less efficient for long distance transmissions because it's difficult to change its voltage. This means that DC would experience significant power loss due to resistance if transmitted over long distances at the low voltages would require for safe use in homes and businesses. This is why DC is used in small little devices and AC is used in homes or buildings. This is how you draw each component of the circuit diagram. This over here is a 3-cell battery. And so one cell would be just this long line and the short line. The short line is a negative and the longer line is a positive. So whenever you're drawing this 3-cell battery diagram, make sure you emphasize the short line and the long line. This is a connecting wire and it pretty much connects every single component together. This is an open switch, meaning that it's breaking the flow of electrons. That means most likely it's turning off the circuit. This is a closed switch, and this allows electrons to flow. This just shows that there is a switch present in this part of the circuit. This is how you would draw the lamp. So I know it looks pretty confusing, but basically you start here, so imagine there's a line going straight across. You keep drawing the connecting wire, you go up, and you go around, you go back up, and then continue, and then draw a circle around it at the end. This is a resistor, and this slows down the flow of electrons. Think of a resistor like a section of a pipe filled with gravel or sand. As the water or electrons pushes the way through, it has to work a lot harder, creating friction. This friction causes the pipe to heat up, just like how resistors heat up when electricity flows through them. So in the essence, resistors just slow down the flow rate of electricity and causing them to heat up. And that wraps it up for today. If you enjoyed this video, please consider subscribing. Also feel free to comment on what you would like to learn next. Don't forget to subscribe and drop a like.